yeah, so I'm a senior engineer at evaluate.xyz. My name is Lucas. I go by Veganbeef. And so the goal of this presentation is to provide some general tips for Cadence developers, or perhaps other blockchain engineers who are new to Flow, or even people totally new to smart contract engineering entirely. So let me just pull up my presentation here. So yeah. Oh, I forgot to mention, since this presentation is part of the Flow Hackathon, and I'm a Flow smart contract engineer at Evaluate. I guess I'm not going to try and hide my bias towards the Flow blockchain, and Cadence language developer experience. I really think it's kind of bar none in the blockchain space, at least that I've experienced. And so I'll yeah, just putting that out there at the beginning, that I'm sure there are fantastic points that I might not highlight for other languages. So starting off with just kind of a broad comparison of the two languages, right? Cadence for the Flow blockchain and Solidity for Ethereum. Solidity was inspired by JavaScript, or so I've heard. I think that might just be due to the function keyword, but I thought that might even be that comparison might do more harm than good. However, Cadence was inspired by Rust, and then Swift and Kotlin as well. I'm personally not a mobile developer, but it does feel quite rusty to me in a totally good way, of course. Rust is one of the most loved languages out there. So I feel similar vibes between the two. Little things that make the developer experience fantastic. One of them is just like integers are automatically checked. You don't have to worry about overflow, underflow. You don't have to import any math libraries or anything like that. And then, kind of the primary difference, the primary innovation, I guess, of Cadence on the Flow blockchain is the capability-based access control model, which is kind of opposed to an ACL or access control list-based model that you might find on Ethereum or other blockchains, where you check a user address against a list of admin addresses or something like that. In Cadence, kind of the way to think about it is that any user that possesses a certain capability to do a certain thing can do that thing with that capability. So, if you want to give somebody permission to do something, or give a function permission, you just pass the capability off to the function. So it kind of changes the entire way you can think about development on the blockchain. And that's kind of the core message of this talk, I suppose, is that, I can give you all the tips you want, but part of developing on Flow is kind of changing how you think about the way the blockchain works. One of those things that the capability-based access control gives you is that user account storage is totally secure by default. So anything that you put in the account storage is only accessible to that user unless you provide capabilities for it to be accessed outside of that. And that access is only by an explicitly limited functionality, right? So the capability, right, it has a certain set of functions or objects that can be accessed by the capability when it's being used. So you can be very granular about the access control. And you're not susceptible to things like reentrancy attacks due to the way that access control flows through Flow. So you don't have to worry about things like that. And one of the things that I really like about Cadence is the fact that you have a kind of a local scope by default. I've always kind of found that the contract level scope default of Solidity blockchain was a little, Solidity development on Ethereum blockchain was a little hard to wrap my head around. And so, this kind of takes more after the kind of encapsulation that you might expect in, JavaScript or something like that, where you have to refer to the local scope by default, and if you want to refer to the contract level scope, you have to be explicit about that. But again, as getting back to the sort of the broad theme of this talk, I would encourage you not to think of this as Solidity versus Cadence, but as like Flow versus Ethereum, and the way that you do things on Flow and how that's different. So I'll walk you through 4 of these kind of main points that I think are key differences in terms of and how you might think differently about Flow blockchain development, especially coming from, as I said, coming from Ethereum. So yeah, switching to a blockchain-oriented mindset, we'll talk about higher throughput on the Flow blockchain, lower fees, resource-oriented programming, and then, of course, the strong developer support, famously. So, so starting with higher throughput, the average Ethereum TPS is 10 to 15. And so Flow can currently handle like thousands of transactions per second. And I'm pretty sure that the team is working very hard at Dapper Labs to expand that, up to 10,000 or perhaps even eventually 100,000 or so or more transactions per second. And so, how do you take advantage of that in your software engineering? You can think of function calls, resource creation, all these things are less costly, right? You don't, and you can do them more quickly. The availability is there. So you don't have to think of the blockchain as this kind of slow moving glacier that you have to interact with occasionally. You can think of it much more as the distributed computer that it's meant to be. And then the blockchain kind of jumping on that theme, you can think of it as like a real-time data source, right? You can read and write to it effectively in real time. You can get a response, in the same time that you might get from like an API call to a database. So, kind of changing the way that you think about blockchain and the blockchain in the blockchain engineering portion of that. And this would be more with talking about interacting with from an app in a web app in JavaScript or TypeScript or a mobile app. But you can think of that blockchain as differently. Lower fees. Obviously fees on Ethereum are notoriously high. Flow transaction fees, if you're not familiar, are just fractions of pennies. They're extremely negligible, to the point that you can companies often fund user accounts and take care of transaction fees indefinitely. It's much more predictable than Ethereum's gas market. You can always depend on fees being low. And always being a low cost that you can kind of count on, and so that if you want to say after 1,000 transactions top somebody off with more gas money, it's an easy thing to automate. Minimum storage requirements, that is a different thing from Ethereum, is that there are storage requirements, so you have to have a certain amount of flow in your account to access a certain amount of storage on the blockchain. But again, those are pretty small. In the aggregate, it can be up to a few dollars or $10 required for like seriously massive collections of NFTs and tons of data, especially, certain NFTs store the SVG data on chain. So that adds up really fast. But again, that money sits in your account. It's just a storage fee requirement. So you don't have to actually pay it every time. And so, the way, how can you change the way you think about development based on this? Transaction fees are not a barrier, getting back to that kind of data source idea, a transaction, right? We do have transactions in the traditional database world, right? That's what a read or write operation is. So you can start to think of blockchain transactions as more like database transactions. You don't need to gas golf inside of your contracts or your transactions to try and optimize, for the exact lowest transaction fee. And then, kind of a bigger thing I like to think about is that state is not a limited resource. I mean, don't go crazy, right? Don't fill up the blockchain with spam, but complexity is okay, right? Complexity in your data model, complexity in the architecture of your smart contract. You kind of want to focus more on proper architecture and human readability over, optimizing for some kind of virtual machine, that is kind of unrelated, this unrelated abstraction. So, you can, again, state not being a limited resource, I think, is a huge change and a huge advantage to in terms of what you can do, unlocking tons of new things on the blockchain. So, as we mentioned earlier, capability-based access control, this is a very related concept of resource-oriented programming. On the Ethereum blockchain, you will use, a central ledger, right, to track ownership almost always, whether that's NFTs or tokens, currency tokens. You're going to have some kind of dictionary somewhere that's going to map addresses to IDs, or addresses to balances, or IDs to addresses. And so, that kind of way of thinking is, some might say, a little antithetical to the whole decentralized nature of the blockchain. But that doesn't exist on Flow. So instead of having a central ledger, you have resources, right, which are kind of first-class citizens that represent assets in Cadence. And you can think of them as being similar to linear types, if you're familiar with the programming concept. Linear types can only be consumed once, so resources can be consumed multiple times, but Beyond that, they can't be copied, and they must always be returned to some storage location at the end of a transaction. That might be user storage, or perhaps somewhere inside of a contract. And then you have distinct, like, resource-specific syntax, right? The @ symbol, if you've done some Cadence development, and strict rules that are applied specifically to resources that kind of are like safety guidelines for the developer. We mentioned capability-based access control, right? So that's all built into the resource. As I mentioned earlier, when you save a resource somewhere, there's kind of natively no access to it. You have to go out of your way to explicitly define what can be accessed and by whom, by creating capabilities. And so, in terms of changing your programming style, it's harder to mess up anything with tokens or NFTs. And it's less scary, right, to do these kind of what might be big operations, high stakes. The stakes are still high, but it's harder to mess up. So it's easier to try things. And specifically, like, user asset management is amazingly easy. You can think about complexity in your asset data structure, right? So what might be super complicated on Ethereum, like having a child NFT that's owned by an NFT, or a child of a child, grandchild NFT, to track, I don't know, I'm thinking of Neopets randomly, so you can have your pet and your pet, right? So something like that kind of application is super simple on Flow, because you can have a complex resource data structure that can have some kind of, dictionary to own other resources inside of it. I mean, you can keep going down the line, so to speak. So effectively, you can use resources to track any and every, like, data structure that might represent real world value. In-game items, achievement badges, brand loyalty points, milestones, things like that. So I would encourage you to sort of expand your conception of what can be a resource, what can be, like an NFT effectively. Expand the concept to include everything. And then finally, the developer ecosystem is incredibly strong for Flow. The Flow team is very supportive. Obviously, we're here with because of the Flow Hackathon, and the documentation is just fantastic. Getting started with Cadence development is super easy. The native documentation is amazing, and there's a ton of good, like, technical writing and explainers out there, unofficially. And then the developer ecosystem is growing and very encouraging in terms of writing feedback and things like that. And so how do you take advantage of this? This one's a little more obvious perhaps, but I would encourage you to go dive deep into the docs if you haven't, on developers.flow.com. The guides are fantastic. They obviously have a strict formal API reference, but there's kind of plenty of examples, and it's very easy to get started, and even to find kind of complex operations. Search functionality is great, so no complaints. Lots of ecosystem tools that I would encourage you to get to know. There's you can actually do unit testing in Cadence with the Overflow tool by Viartech, and I'll provide links to these things after the talk. But there's also NFTCatalog, right, and MetadataViews, which I'll talk about in a bit, and as well as a couple smart contracts from Evaluate. And so and finally, Discord. The Discord scene is great, super friendly and helpful, both on the Flow official Flow Discord, and also, like, I like the Flowverse Discord a lot. And then it's very open and evolving language in terms of if you want to submit a bug on GitHub, or you have an idea for a new language improvement. They call them flips, right? Flow language improvement proposal, I believe. And so people are super open to if you want to talk about an idea, or even formally submit a flip on the Flow forums or on the GitHub pages. It's very welcoming. So I encourage you to check that out, and make the blockchain into what you need, what you want, if possible. So, moving into kind of the Cadence, explicitly Cadence focused portion, I suppose. I'm going to talk about some things that I have run into as I was getting started with Flow blockchain development and things that maybe stumped me at first, or that weren't entirely clear to me. So hopefully you can learn from those and not make the same mistakes as me. So starting with static and runtime types, there is a two-class system when it comes to types in Cadence. And so static types are what's used by the type checker, right? Those are what you might explicitly import from another contract. You might say NFT storefront dot storefront, right? That's a static type, and so you use that for type annotations, like the borrow function accepts it, right? In your little brackets. Those are static types. They are not allowed to be dynamic. So anything passed to get capability, for example, as a static type argument, that has to be explicitly imported or locally defined. And so if you're coming from TypeScript background, generic types are not a thing. They do not apply, at least not to static types, not for now. Could be changes coming there. There's definitely a lot of talk about that on the Flow forum. But yeah, for now, generic types do not exist. But runtime types are kind of the second class, so to speak, of types. They are denoted by the type keyword, and they can be used like any other runtime value. You can store them in a variable, and you can run Boolean checks or comparison checks against them. They do accept a static type as an argument, or they can, right? If you create a type by saying type and then passing the brackets, you can define, a static type based on a hard-coded runtime type. That's the structure you'll find in like catalogs, right? The NFT catalog or the like various fungible token catalogs out there. Another way to get a runtime type, is to construct it with the composite type constructor, or there's a couple other type constructors you can use. But the key thing to know is that, like I said, you can't pass them as variables into somewhere where a static type needs to go. So they're primarily useful for like checking a type and verifying a resource is authentic. It comes from the contract that you think it is, right? If you want to be trading Top Shot NFTs, you want to make sure that the type exactly matches the Top Shot NFT type. And that's when runtime types can be quite useful. But do not go down the rabbit hole of trying to turn a string into a import or a capability type. It's not possible. Yeah. So please avoid those pitfalls if you can. Authentication methods, verifying assets. So this, due to the different access control model, is quite different in Ethereum and stumped me a bit at first. No message sender, right? No message.sender. So the only exception there is that in the contract init function, you can call self.account. That's effectively the same as message.sender, but that's a very limited use case. And so aside from that, how might you check the authenticity of somebody or some user? I would encourage you to change the way you think about this. Instead of focusing on verifying a user identity, focus on verifying ownership of an asset, or ownership or identity through assets, right? So if you're explicitly dealing with the resource with that @ symbol prefix, it's going to have an owner property that'll tell you who owns it, unless it's just been created. Little caveat there: it'll have a nil. It'll be nil if the resource has just been created and not yet stored in a user address storage. But aside from that, that'll always exist. The most common method I use now is just the address property on a capability, right? So if somebody sends your function a token provider capability to, gives you the capability to withdraw some amount of tokens, that capability is going to have an address property that'll tell you the address that it references, that it's linked to. But then finally, if you do need to explicitly verify like a user address ownership, or you need user to acknowledge some kind of arbitrary data or sign some kind of arbitrary data, you can use manual PGP encryption. It might sound scary, but it's not that difficult. I can walk. Here's kind of a basic walkthrough here. Starting, the smart contract will have some kind of message to send to sign. It'll provide that to the client application. And that client application then asks the end user to sign the data with their private key. And this is the same key that allows them to access their flow address. It's one and the same. So you can use it as a PGP key to sign arbitrary data. The user sends that signed data back to the client application, which passes it to the smart contract in some kind of function call. Then the smart contract is able to be, like, as I said, the user's private key is linked to their Flow blockchain account. The smart contract can just get that user's account and call the public key method to get the public key, and can call the verify function, to ensure that the data came from the end user and the message hasn't been tampered with. So, a bit of a more complex process, one that you might not want to use unless you have a specific use case for it, but it's always there if you need to, really verify that this user is who they say they are, and they haven't perhaps, been passed a capability from another account, as an example. And finally, a couple important contracts in the space that you might check out. MetadataViews is obviously a built-in standard, but I would encourage you to get familiar with it. It's the contract that provides a lot of interfaces for NFTs on the Flow blockchain. So very useful to get to know. And then kind of in tandem with that is NFTCatalog, which you may not be familiar with, but you can check out their Vercel link there. That basically is a public repository of a bunch of metadata, conforming to the MetadataViews standard on a bunch of NFTs. So if you have an NFT project, you should probably register here. A lot of other functionality in the space is based on that. For example, a lot of Evaluate's tools are based on the NFT catalog. If you're not listed there, we don't have you on our platform. So I encourage you to check that out and get familiar with it. There are actually some helper functions on the Evaluate smart contract address, if you'd like to check that out as well. I'll get to that in a sec. DapperUtilityCoin. So a little bit more of an obscure contract, and you'll want to check out the docs for sure if you're going to integrate with this, but this is what you use if you want to integrate with Dapper Wallet and make or accept payments from a user's credit card or their Dapper funds. That payment's going to happen in DapperUtilityCoin, and it's got some special properties associated with it. Chiefly that nobody can own it aside from Dapper. Effectively, they use it as kind of a marker on the blockchain to show when they need to transfer fiat funds. So any contract that involves DapperUtilityCoin involves Dapper sending it to some user, spending it on their behalf, and then those funds going back to Dapper at the end. So a little confusing and a lot going on there. So be sure to check out the docs there if you need to integrate with Dapper Wallet. And finally, I would be remiss if I didn't mention Evaluate's swap contract. I hope that you have heard about our swap platform, which allows you to do peer-to-peer randomly matched transaction or NFT swap transactions, no cash funds involved. And so, it's a very fun product. It's very fun to use. I've been trading a lot of Doodles wearables lately on there. So check it out. And if you want to integrate, which we strongly encourage you to do, you can use the contract for, gifting or in-game trading or NFT, construction, if you want to build a set or things like that. So check out our blog post on the blog URL there. You'll see it. It's the first one there, most recently posted as of now. And yeah, I think that is just about it. Open the floor to questions at this time. Let's see, going into the Q&A.
Okay, I don't think any.
No questions.
Any questions?
I guess I was too thorough for y'all.
If anyone, if you have, I think we have got our first question. Do we need on the GitHub repo both mainnet and testnet contracts?
Yeah, so most GitHubs, and I'll provide a lot of these GitHub links in a follow-up email, but to all of participants. But yeah, most GitHubs that you'll see will have a README that provides your mainnet and your testnet values. It's sometimes can be hard to find other ones if they're not listed, like testnet addresses. I'll try and post some of those in that follow-up email as well. If there's any hard to find ones that I have stored. Yeah, would be, maybe an idea for a project, right? To have a public repo of testnet addresses. I don't know. But thank you for your question, Karina.
Yeah, I hope that answered your question. Anyone else has any other questions? Okay, so what is a major drawback of coding on Flow as far as decentralization?
Yeah, I mean, Flow got a lot of blowback initially. When they kind of spun up the blockchain, it was very centralized at first. And I think, well, that has quietly gone away behind the scenes. The team has been working and continues to work to increase decentralization. They're opening up, access nodes to the public now, things like that. So that's obviously not reported on because it's not as exciting. But yeah, I do think that, they made the decision, right, when they were building this thing to go fast and build an amazing product. And the one thing they did trade off initially was decentralization, but I think they're slowly, giving that back to the people. And I'm very happy with the way it's going.
Yeah, thank
All
you.
right. And thank you for your
Those
question.
related to metadata view and NFT catalog, that would be highly appreciated.
Yeah, I'll make a note. Those, yeah, I definitely remember having trouble finding those testnet addresses as well. So I'll send those along, Karina. Thank you. Jennifer Sudo. Jennifer is a colleague of mine at Evaluate. I should let you know. But so Jennifer says I'm not a coder, so a lot of this went over my head, but I love learning about cadence and appreciate you sharing your expertise. Thank you very much, Jennifer. I appreciate the comment and glad you could come and join. And yeah, I hope this will be helpful for anybody here who's joining the hackathon. I wish you the best of luck.
Uh, like also, can you share some tips and like what they should do during hackathon, how to follow, what documentation if they are new to Flow, so what documentations should we follow, or what can be the point of reference so that they don't get stuck sometimes when we go to the hackathon and we don't know where to start, so we get stuck. So like how do we start with Flow, and what something tips and like this that can help the participants?
Yeah, I would encourage you, if you're kind of stuck in that position, I would encourage you to check out there's a really nice like tutorial flow it's just on the official Flow documentation site, which is developers.flow.com. And so you can go to the guides section and they have like a walkthrough explainer of, how to set up a storefront, how to mint, fungible token currency, how to mint NFTs. And there's links to the Flow playground in there, and so that'll take you to like an environment that's like already set up with all this code, so you can just kind of walk through and poke around and very quickly, if you're that kind of a learner, like I found it super helpful to be able to just go in and see something simple that is working from the inside and play around with it. So I think that's the best resource I found out there for, if you're stuck, if you need an idea or you want to figure out how to do this one weird transfer or something like that, go check out the guides. They have kind of all of the basic flows, so to speak, mapped out for you.
Yeah.
And then aside from that, I know Build Space is the other one I would shout out. They've recently released a Flow blockchain track, and I've heard very good stuff. I haven't done the course myself, but
please do share all the links and references that you have. I'll share with the participants. That will be really very great and helpful.
Absolutely.
Okay, so like we'll wait for a couple of minutes. Anyone else has any other questions regarding the hackathon? Maybe regarding okay. When will the hackathon be officially over? So the build phase overs on the 26th. That's the last date when you have to submit, and after that, the best projects will be taken into launchpad, which will means which the team will help to build, and you can get more guidance on that. So yeah, that's. I hope that answers your question. Okay, so I think if we don't have any other query, then we can wrap up and you guys, if you want to share anything else, like you want to give any final words before leaving.
Yeah, I mean, I think everybody here knows that it's a super exciting time for Flow. You know, lots of things happening, and yeah, I encourage you to build off of that hype. You know, go with it, run with it, and I'm excited to see what people make. Oh, and I should add there is a small $2,500 extra prize for anybody who builds on top of Evaluate's swap contract, and so that's any submission is open to that prize. Just the best use for the
Can
swap
you
contract. So
elaborate more about something about swap contract like that you have mentioned now?
yeah, sure. So it's the contract underlying evaluates like front end swap client. So that what I mentioned earlier, like kind of peer to peer NFT trading with a very slick drag and drop user interface. The back end is pretty slick as well. It allows you to create, effectively create a single peer-to-peer offer with exact, all tokens specified. I'm going to give you these ones, you're going to give me these ones. And then it ensures that all goes through when the other person signs. So it's totally safe, great way to do in-game trading if you want to have some kind of game interface, or gifting is very easy through the platform or through the contract. So lots of things you can do in terms of transferring NFTs around in a safe way. And so, yeah, please check that out. And yeah, if you build on top of that, you'll be eligible for that extra prize. So.